Finally, in 11.7, we wrap up the chapter. We looked at position control and how we can leverage the ROS control plugin in Gazebo to do robot control. I might also add here that ROS control is a great way to do controls in ROS because you can use exactly the same software both with real robots and simulated robots. The controller manager is very flexible and allow us to use different control interfaces to work with our robots. We saw how configuration files allow us to set the parameters for our different controllers, whether they're position controllers or joint state controllers. We saw how we can integrate all the different controllers through the namespace. We also looked at velocity control, and we used the same plugin but a different hardware interface. We saw that the analysis of the dynamic response was a little bit harder as we pushed the sine curve input, but we also looked at some techniques to facilitate the analysis of our controller. When it came to force control, we actually reviewed an admittance controller. Using the NAC code, we basically were computing an error in our position from the desired location to the actual location due to external interaction forces, and then we used the NAC code or the admittance controller to reject the disturbances and output velocity command updates to come back to the attractor point. Finally, we introduced trajectory messages in ROS. We started with a 1 degree of freedom and then moved to a 7 degree of freedom example. We saw that commonly in ROS we're going to use action client server nodes to generate our motion, and the client is normally in charge of devising the path while the server is in charge of doing the interpolation, whether it's Bezier or perhaps doing something more dynamic using motion planning or a similar technique. So I hope Chapter 11 was interesting and useful to you as we entered into the manipulation space in robotics.